Okay, so good afternoon to everyone. Now in today lab class, we will see how to design the encoder and how to design the decoder. These two we will see using the multisim, how we will able to design. We will see that in today's class. So first, before starting the making of the circuit, we will discuss about that what is our encoder is, then we will discuss that the decoder. So step by step we will discuss it. So mainly encoder is what encoder in our digital circuit, digital logic, that encoder is basically a combinational circuit. Everyone know that it is the combinational circuit that performs the reverse operations of a decoder. The encoder, when I have discussed the parallel priority interrupt, you have seen that in the parallel priority interrupt, we have the 4x2 encoder is present. That means there will be the 4 input and 2 output. So same as that encoder, here also that encoder is, that means encoder can take what? Encoder can take maximum 2 to the power n input lines. That means whatever the input line will be, let's say total input line is what? This is, let's say, the encoder we have. This is the encoder, and in this encoder we have 2 to the power n number of lines, 2 to the power n input. So whatever the input will be the 2 to the power n. And what will be the output? The output will be n. The output will be n output lines. So 2 to the power n input lines, and output line is what? N input output lines. So that means if we put 1, then in the in the value of n, if we put 1, then that means 2 input lines and 1 output line. If we use 2 there in place of n, then there will be the 4 input lines and 2 output lines. So that's how the encoder is. And it will produce what? It will produce a binary code equivalent to the input, which is active high. That means what is active or high, it will produce that. Therefore the encoder encodes to the power n input lines with n bits. Now in today's example, I will show you the 4x2 encoder. This 4x2 encoder means what? There will be the 4 inputs in this encoder. There will be the 4 inputs and the 2 outputs will be there. And at any time, only one of these 4 inputs can be 1. So that means the 4 inputs we are giving. And at a time, these things you should have to keep in mind, that at a time one of this input will be 1 in order to get the respective binary code at the output. That means one will be active, the other, all the others will be deactivated then, and that will be shown in the output line. That means if there is a 4 input, then at a time one output is what? Among this input, one will be activated. When we get the output, in that time one will be activated. So that's why if we represent it into the truth table, let's say we have our out input. So for input, let's say we have input y3, y2, then y1 and y0. These are what? These are the inputs. Let's say we have these inputs and we have 2 output. So this is 4 inputs are, so 2 to the power 2, that means 4 inputs will be present. And how many output will be there? N value is 2. So that means we will have 2 output. Now, what will be the truth table? So first case, if we see that the truth table of it will be, let's say this is activated now. This is activated. In this case, what will be the output shown? 0, 0. If in this time it will be 0 and 1. If the next case 0, 0, in this time, let's say this input is active. So this will be what? 1, 0. And the last will be what? 0, 0, 0, 1. In this time, it will be 1 and 1. So this is what our encoder is. So using the 4 inputs, the 2 outputs, and what will be the truth table? This is the truth table of an encoder. So now we will design and see how this encoder design using the circuit design, how it should be prepared. We will see now. So first, what we have to do? First, we have to use the, let's say here in this diagram, we have to use the already 4 inputs are there. So 4 inputs means we have to use, let's use 4 switch. The 4 switch has to be there, and there is what? There is, we require the OR gate. We also require 2 OR gates in this designing this circuit, and we will require a ground voltage and a DC power supply. And for seeing the output, that the LED should be our LED or the probe blue or probe orange. That means for indication purpose, whatever the indication purpose we are using, that indication purpose indicator should be present, so that we will able to verify our truth table. So this is what these components are required to design the encoder. Okay, so now let's start to design. So first we will require the switch. So how we will do the switch? You will see there, we have already discussed about that. Using the control W, you can go. Using the control W, you will open, but you can also open using the TTL format also. But okay, we will open with the control W. Pressing this control W, the window will be open, and from there all groups we will choose the basic, and from this basic we will go to the switch, and in this switch you will see a switch named DIPSW1. DIPSW1. So this switch we will use another, because we have 4 inputs here. So we use the total switches. Now 4 switch we have used. Now we require 2 OR gate. So how we will choose? From here we will choose the, from group you will go to the TTL, and in this TTL use the component name 74LS32N. Okay, you have to choose 74LS, and from there go to the 74LS, and from there choose 74LS32N. This should be chosen, 74LS32N. So we choose it first. Now here you will see like this window will open. So from here, first you should press A, then it will come, and another one that will be again A. So these two types of OR gate we have chosen, these two OR gates. Now we require what? We require a DC power supply, a ground voltage, and the for indication, a indicator, two indicator is required. So again, we will open the components list, then go to the all sources, and from these sources, we will choose the DC power, then use the ground, a ground voltage should be there, and again go to this group, and from here choose the all group and choose the probe blue. So this will be, and this will be another probe. Okay, so the components which are required we have already used there. The components which will be required, we use it. Now we will make the connections. So this voltage value should be changed, and this will be the 5 volt. Now we will make the connection. So first connection should be made. Now and okay, so the total connection is made now. This is the total connection we have made. Now we will verify the truth table. So one by one we will verify the truth table. So the first condition is 1 0 0 0. In that case, the first is what? The first, our first input will be active and other inputs will be deactivated then. Then what we will see in the output? 0 0. So let's see that it happens or not. You see 1 0 0 0. So here it is 0 0. No lights are shown. So that means what? That means it is indicating 0 and 0. So this is verified. Then next condition is what? 0 1 0 0. In that case it will be 0 and 1 in that case. So let's see, we do that. Yes, 0 and 1, 0 and 1. It is showing 0 and 1. So it is light up. So that's why it is 0 and 1. Then the third case is what? The third case is 0 0 1 0. The third case. In that case, it will be 1 and 0. So let's see that. So open it. You see 1 and 0. So it is proved. Then next, the last condition is 0 0 0 and 1. So here it will be 1 and 1. So 2 will be 1. So that means here what we will do, we will open this and we will close that. So close means 1. So here you see that 1 and 1 both are lit up. So that's how the encoder 4 into 2 encoder can be done. Okay, clear to everyone?
Yes, sir.
Okay, so I will give you some time. You will design that, and after that I am giving you the 10 minutes time. So you prepare it and then I will see your thing. Okay. So everyone prepare it and then I will see it. Okay. So now one by one, I will see your programs, the circuit design you have. One by one, I will call off your names. You will show that. So first, Tania,
Yes, sir.
can you show me? I am giving you the permission.
Yes, sir.
So show it. Okay. So start running it. First 100, okay. Then 0100. Okay. Then 0010.
What, sir?
0010. The next. Okay. And then 0001. Okay. Okay, it is correct. You stop sharing.
Thank you, sir.
Then next, Roshan. Roshan, are you here? Roshan Kumar.
Yes, sir.
Okay, Roshan, can you show me? Can you show me the circuit design which I have shown you? Have you prepared it?
No, sir.
Then why? Because I have already shown you that how to install it, how to you can install this, how you can everything in the class I have said you that how it can be installed. But till now you didn't install in your system this software. Okay, it is up to you that what you will do. I will show you the programs and I will go after that. It depends upon you that what you will do. Then next, Preeti. Preeti Kumari Singh.
Yes, sir. Sir, can I show it after 5 minutes?
Okay. You can show that after 5 minutes, no problem. Then Aditya,
Yes, sir.
can you show me Aditya?
Yes, sir. Connecting from laptop.
Okay. In this meantime, I will see the other person like Rehan. Can you show me?
Sir, I don't have laptop now. Can I show you in the next class, sir?
Okay. So you have installed the software in your system. You have already installed the software. So
Yes, I have installed, but I don't have my system now.
okay. You give it in the next class. You will show that. I will see your the thing in the next
Yes, sir.
class.
Yes, sir. Okay, sir.
Then Sanjay.
Sir, may I?
Connected.
Yes, sir.
Okay. Show it. No problem.
Is it visible?
Yes. It is visible. It is visible. And 100, but your circuit is somehow there is a problem, because if this is 100, then there will be 00, means no light will be shown. In that case, no light will be shown. So I will see it. तो हम एक बार देख लेते हैं, तुम्हारा सर्किट का कोई दिक्कत हुआ है, सर्किट का प्रॉब्लम हुआ है। कनेक्ट किए हो, देन इसका कनेक्शन, अच्छा इसमें कनेक्ट किए, देन इसको कनेक्ट किए। तुम इसका वोल्टेज अभी तक चेंज नहीं किए, 12 वोल्ट की जगह 5 वोल्ट करो। ये जो 12 वोल्ट है ना, उसके ऊपर क्लिक
Yes,
करो।
sir.
हाँ हाँ, देखो 12 की जगह 5 कर दो। स्टॉप करके फिर रनिंग स्टार्ट कर दो। अच्छा, और एक बार देखना दो, तुम इसको कनेक्ट किए हो। ओके, 5 ही है, ठीक है ठीक है, 5 ही रहना, 5 वोल्ट। ओके, पूरा ओपन करो तो एक बार, ओपन कर दो, ओपन कर दो। S3 to N, U1A, U2A। S2 को कनेक्ट किए इसके साथ, S1 कनेक्शन इसके साथ किए थे। तुम जो स्विच जो चूज किए थे, स्विच कौन सा स्विच चूज किए थे? DIPS जो DIPS W1 चूज किए थे स्विच?
No, sir. SPST.
हाँ हाँ
Sir,
हाँ, इसलिए दिक्कत हुआ। वो जो स्विच था, उस स्विच तुमको चूज करना होता था DIPS W1 जो हम दिखाए थे, DIPS W1 स्विच चूज करना होता, तब ये होता। वो स्विच जो है ना, स्विच चेंज करके सॉरी, स्विच चेंज करके DIPS कर दो,
okay,
DIPS
sir.
W1। कंट्रोल W करके ओपन करो, और जो कंपोनेंट को ओपन करो एक बार, कंट्रोल W करके स्टॉप कर दो। हाँ, स्टॉप कर दो बाद। हाँ, इसमें जाओ, सोर्सेस के जगह में ऊपर ये क्लिक करो। बेसिक बेसिक, और स्विच स्विच, फर्स्ट स्विच में जाओ, स्विच में जाओ। नहीं नहीं नहीं, इधर लिखा है देखो, लेफ्ट साइड में स्विच। हाँ, स्विच के में जाके लिखो DIPS, DIPS। हाँ, फास्ट वाला जो स्विच है DIPS W1, ये स्विच तुमको चूज करना होगा।
Okay, sir.
ये वो सब स्विच को डिलीट कर दो, फर्स्ट इधर बाहर में करके रखो, फिर वो डिलीट करके उस जगह में दे दो।
Okay, sir.
अब एक एक करके तो हो गया है, इसको हाँ प्रेस करके देखो, राइट क्लिक करो, राइट क्लिक। हाँ, हम्म इसको इसके साथ कनेक्ट करना है। ये जो है तुम इसके साथ कनेक्ट किए तो S7 का जो है वो लाइन डिलीट कर दो। हम्म
Is it okay, sir? And this one?
ना इसको इसको ये जो है ये वाला जो लाइन है, ये वाला जो लाइन है तुम इसके साथ कनेक्ट कर दो। और वो टोटल कवर जो राइट साइड में तुम किए ना, मतलब
हम्म।
ये जो S5 के इधर से राइट साइड से जो लाइन तुम दिए वो लाइन उधर
हम्म।
से डायरेक्ट कनेक्ट नहीं होगा। S5 का राइट साइड जो लाइन है।
Okay, sir. ये सर ये वाला लाइन
नहीं नहीं नहीं, ये वाला नहीं, ये वाला नहीं, उस साइड में जाओ। ये इस साइड
ये
में और हाँ इसके आगे जो लाइन देखो, ये जो कनेक्शंस का लाइन है, हम
तो
एक
जो
बार दिखा
सेलेक्ट
दे
हुआ है
रहे
वही
हैं।
ना?
हम एक बार दिखा दे रहे हैं, रुको एक मिनट, हम तुमको दिखा दे रहे हैं। हाँ देख पा रहे हो?
यस सर।
हम्म
So is it okay?
रुको हम शेयरिंग स्टॉप करते हैं, नहीं तो हम देख नहीं पाएंगे तुम्हारा। अभी ये करो, रन करो उसको।